Greetings viewers, in this video we'll attempt Cambridge A-Level Further Mathematics. This is Component 3 Further Mechanics, Variant 3 from the May June 2025 series. We will attempt question 1 in this video. A particle P of mass m is attached to a light inextensible string of length A. The other end of the string is attached to a fixed point O, and it moves in a horizontal circle with a constant angular speed omega, with the string inclined at an angle theta to the downward vertical. So first let's sketch out what this looks like. So it's a light inextensible string, so we cannot make it as a spring, and we don't need to consider the weight of the string because it's light. So that's the assumption that we make here. And at one point it's fixed at O, and the other point has a particle P with a mass, and it's inclined to an angle theta where tangent theta is 4/3. So let's say we have a ratio here, and that's theta, so 4, 3, and we can resolve for the hypotenuse, which is 5. So there's a trigonometric ratio there, and it's also spinning in a horizontal circle with a constant angular speed omega, and the length is A. Okay, the length of the string is A. So let's try and sketch or label some of the forces here to make sure that it is easier to deal with. So there's weight, there is tension, and the resultant force, obviously there will be a resultant force because it's moving in a circle. So the resultant force will always be to the center of the circle, and that will be the centripetal force. I think that's enough information for us to start solving. And also we'll assign our axis, since most of the forces are pointing towards the right, or I sketched it towards the right. So I'll assign the x positive towards the right and y positive upwards. Okay, so there's no net force in the horizontal, no, not horizontal, the vertical direction, right? So Newton's first law of inertia, there's no net force, so there's no acceleration. So F, the sum of F in y, that will be 0. So out of the sum of the x forces in y, we have tension. Tension, you can resolve it to its x horizontal and y x and y components, vertical and horizontal, which ty will be, because theta is here, right? Theta is this one, so ty is touching the angle, so there will be t cosine theta. Tx, meanwhile, there will be t sine theta. It's opposite the angle. Okay, back to the forces in the y direction. Ty is pointing upwards, so there's a positive t cosine theta. And mg is pointing downward, so there's a negative mg equals to 0. So we have, rearranging, you have t cosine theta is mg. You'll label this as equation 1. Now we have the sum of forces in the x direction. But in this case, there is a resultant force, and that is given by the centripetal force, Fc. If you forget what the formula is, yeah, it's here. The centripetal acceleration is given by these two expressions. But in this case, we'll use the omega square r since we want to find the omega. So we just replace it m omega square r. So there's our sum of forces equals to our resultant force, which is the centripetal force. And Fx, first we have the tension in the horizontal direction, which is pointing towards the left. So there will be t sine theta, a positive value. Also, that's it, right? In the horizontal force, there's only one force. Then equals to this one, m omega square r. Okay. What we don't have is the r, the radius. So the radius, actually, what is it, is this from the center, and the distance from the particle to the center, that's our r. But luckily we have the hypotenuse is a, and we know this is theta, so we can use a sine theta to represent r. So you can write as a, sorry, not a, r R will be A sine theta. Okay, using trigonometry. So I'll rewrite it down here and we'll label as the second equation. Now we have unknown T, unknown M, and A A is not really an unknown because we can leave it in terms of that. G is also not an unknown because there's a the gravitational acceleration. So we have two unknowns. No, we have three unknowns, right? Three. T, theta. Oh no, theta we know. Okay, so T and M and omega. But we can use this one. Equation 2 divide by 1. So on the left hand side we have T sine theta over T cosine theta. And on the right hand side, M omega squared A sine theta divided by mg. So T and T cancelled, M and M cancelled. And sine over cosine, that just gives a tangent. On the right hand side, omega A sine theta over G. So G and A, we just leave it there first. But sine theta, we need to resolve it. And we have the information to do it, right? Using this trigonometric ratio, we should get opposite is 4, hypotenuse is 5. So 4 over 5 here. And tangent theta, we also given in the question as 4 over 3. So we just substitute the values. And you should be able to get this final expression of omega. Yeah, omega is in terms of A and G, which is our final answer here lah. Yeah, so that's question 1. Thank you for watching.